This video is sponsored by PCBWay, a leading company specialized in the manufacturing of professional PCBs. New customers that register on PCBWay site get 10 PCBs, 2 layers for free. The build time is only 24 hours, with a typical shipping time from 1 to 3 days. Upload your Gerber files on the site, check the technical specification for manufacturing, and then just wait. Subscribe to the I Can Solder Kit 2019 and win up to $800 in prize. Check this out. Today we will see the repairing of this power supply, that is a Longway PS305D, that has a problem because with overload it is always in protection mode. So even if the power supply is switched on, there is in the condition of overload. So the LED is red and the measuring are always 0. This condition is permanent, even if I try to change the settings. I think there is a fault that is affecting the short circuit protection circuit. Searching on the internet, I found this scheme that is representing in 3 pages all the power supply architecture. Starting from the line and phase, we have a transformer that transforms the power supply line in 22 volts alternating. Then there is the bridge rectifying and the 2 regulators, the 7815 and 7915, that will create the plus 15 and minus 15. Then all the comparators are managing all the power supply architecture. On the power stage, we have the rectifying of the power supply, and we have a relay that will switch between high current and low current mode. So starting from the transformer, we will have the 2 possibilities of current. In this stage, we see the bridge rectifier, and I highlight the path of the current by following the arrow. So the continuous current is feeding the 2 power switches that are 2 BJTs, and then we have a sense resistor in series with the negative, and therefore the current is sensed at this stage. As a first verification, I will check the power supply values, starting for example from the 15. This is the unboxing on the power supply, and we see the big power transformer that is connected to the primary line and neutral, and this is the main board. Then we have a fan that is dissipating the heating of the final power switch. These are 2 2N3025. So I will search now what are the regulators for the power supply stabilization. Here we have the 7815. First check is the measure of the power supply output. So I will put the probes between the output and the ground on the first regulator of 15 volt. I read 14.69. That is okay. That is a good value. Then about the negative regulator, I place the probes between pin 3 and 1, and I check the negative power supply, that is minus 14.86. Also this is okay. At page 3, I will analyze the front panel user interface. So this is the LED that is always on, and I find two potentiometers that are setting the current value between coarse and fine regulation. These signals are collected to a connector. So in order to get the signal from the potentiometer, I will use this connector, that is a standard one, and I will connect this connector directly on the points that I have to measure on the potentiometer. So from the connector, I will get the two wires connected to the potentiometers. If I have the two potentiometers connected to the maximum value, I find a value of 12 kilo ohm. If I trim, I see that the potentiometer is correctly working, down to a resistance of 1 kilo ohm. Then this is the other part, and I check that the potentiometer is okay because I go down to 10 ohms. So the two potentiometers, I think they are okay because they are covering all the range. Then I check also the other potentiometers that is related to the voltage regulation. I will connect my probes on this connector, and with this mode I will check the resistance of this potentiometer. Also in this case, if I change the potentiometer trimming, I found a correct resistance changement. Also in the other side of the potentiometer, I found a correct value of low resistance of the potentiometer. So I will check now the other potentiometer, that is the fine regulation. I use two resistors in order to catch the test point of the resistor potentiometer. With this mode, I check also this potentiometer that is okay, because is varying the resistance accordingly. So all the potentiometers are okay. Now, by checking all the semiconductors, I found this diode that was in the short circuit. And this is very annoying because this diode connects the plus of the power supply to the power switch, the final BJTs. This diode has been removed. I have a little difficulty in doing that because it was an old diode. And then I will replace this diode with a new one that is a bigger diode directly soldered on the pads. The main control of all the power supplies is related to this LM324 IC. There is a 4 comparator integrated inside this chip. These comparators are managing the protection in current and in voltage. They read a reference voltage of minus 11.3. They compare the actual voltage, and if there is a voltage bigger than the threshold, the power will cut down. I check the resistor partition and with this resistor value. So I calculate what are the voltage of the threshold, and then there is something that is go wrong because the levels are not as expected. I completely removed the LM324 by using the desoldering station, and I will replace it. I put a socket on the main board and I replace the EC. I will check now the voltage. Now I have a good voltage because it's minus 11.3. So the LM324 was broken. This also is a good voltage, 13.7. Then there is the power command, that is the enabling, that is 13.7. So the power is enabled. At the end, at the 14 pin, I add the Vout, that is the negative voltage of minus 13 volts. So the control part has been correctly repaired. Now there is no more default because the LED now is off, is no more on. But if I move the voltage regulation, I have no voltage outside. So the fault of overload has been removed, but the control is no more okay. I check now the BJT and the connection they have with the control part. I have 2 diodes in OR configuration, so the enabling of the power stage is given only if there is a good value given by the comparators. We have now Vout that is low, so there is something wrong with Vout. So I come back to the input of Vout comparator and I will check if there is a fault in the input part. For the current readings, there is this HR1774, that is an op-amp, that make the readings of the current. So I will check now this chip. I replace it with a new one, with a socket, with a TL081. That is an equivalent that can be good for this kind of operational amplifier, because the parameters of gain bandwidth are okay. With the new op-amp, now I have the current that is no more 0. I have a little current with an offset, even if I have no load inserted. I have now moving the potentiometer in order to put 0. If I trim this potentiometer, I will reach 0 with no load. Now the trimming has been done by moving this potentiometer. Okay, now I think the instrument is repaired, because if I turn on, 0 and LED green is on. I will put a very high load on the output, and I will check the voltage with a fluke multimeter. Then, now, voila! The power supply is working again, because I can move the voltage and I see the current that is flowing. So we have make the repairing. I will check now higher voltage. Because I have 100 ohms, the current is 100 of the voltage. So perfect. If I look at the fluke measurement, it is coherent with the display. So, in conclusion, the faults were located in the comparator and also in the current sensing op-amp, and also in the power diode. These three elements were the fault of this power supply. So, with this fault, the enabling of power was cutted. Okay, and I remember also I checked this diode before and I substitute with a big one. This one was another operation that was not working properly, and I substitute with a TL081. So this power supply is about 150 watts capable and has been repaired. The final test will be done on a high power load. So I will put 10 ohms resistor, 5 in parallels, in order to have 2 ohms equivalent. So if I will put the 30 volt on 2 ohms, I will have a very, very high current. Now we turn on. Okay, 5 amps, that is the maximum current limiting, over 24 volt. If you see, the magic smoke is because the resistors are too much stressed. So also the power test has been concluded. Bye!